Hi, this is energy policy. The importance of energy. Everybody uses energy, so this is a relatable topic. All persons, natural, meaning humans, and artificial, meaning organizations, need energy to survive and thrive. In economics, energy is a universal cost component. Its price influences the prices of goods and services. Herein lies the connection between energy and money. Both are universally used and universally needed in a modern society. And the price of energy, its monetary value, is directly connected to the price, monetary value of everything in the economy. So the higher the cost of energy, the more expensive everything else is. And the lower the cost of energy, the less expensive everything else is. Breakdown of the United States energy sources. As of 2022, the United States energy sources approximately fossil fuels 78%, and of those 78%, almost 32% come from natural gas, 28% from petroleum, and almost 18% from coal. Nuclear, 8%, and renewable sources, 13.1%. So while in 2022, renewable energy accounted for only about 13% of the US total energy consumption, it accounted for about 21.5% of electricity generation. Distribution of electricity generation worldwide in 2022 by energy source. What we can see here is that unfortunately coal still constitutes the plurality, meaning more than any other source input in terms of producing energy. So coal accounts for almost 36% of all electricity generated in the world, whereas nuclear just over 9%, hydroelectric 15.2%, natural gas 22.2%, among other big ones. So coal that we use today was formed from plants 359 million years ago to 299 million years ago, long before the age of the dinosaur that appeared 230 million years ago. This is to the point that sometimes people claim that fossil fuels, including coal, come from the bones of dinosaur, and that's just absolutely not the case. Oil formed from small organisms like plankton and algae. So coal, again, is from plants. Oil is from small organisms. And the oil we use today was formed between 252 and 66 million years ago. Oil is the most important fuel for transportation in the United States and also globally. And we also have natural gas, which formed from the same organisms as oil and in the same time period, but under more heat and or pressure. In order to understand why fossil fuels continue to dominate production of energy in the world, we have to take into account the techniques that were developed in the 20th century for extracting new sources of oil and natural gas. The two techniques that I have in mind are hydraulic fracturing, commonly known as fracking, and horizontal drilling. They change the energy picture in the world, and particularly in the United States. Relatively speaking, these are old techniques. So hydraulic fracturing goes back to the late 1940s, and horizontal drilling goes back to the 1960s. But what happened was these techniques are being put to use in ever new locations because new shale gas and oil deposits are being discovered, and combined with the improvement in technologies of these techniques, fracking and horizontal drilling, we have achieved in the United States by 2018, 2019 maybe, virtual energy independence. The dramatic change occurred between 2005 and 2019. So in 2005, the United States still imported approximately 60% of the oil it used. By 2019, it didn't have to import any, but it still did some for logistical reasons, just as it exported some. So there are cases where it's convenient to import for logistical and economic reasons, even if you are a net exporter. So in 2019, the United States became the world's top oil producer. Let's look at the chart of leading oil-producing countries in the world in 2022, and it has numbers in thousands of barrels per day. So if you look at 2022, you will note the United States is by far in the first place, with nearly 18 million barrels per day produced. Saudi Arabia is distant second with just over 12 million barrels a day. So the United States leads second place Saudi Arabia by almost 50%. Then we had Russia with just above 11 million barrels a day, the number that I'm sure has since fallen because of Russia's war against Ukraine. Canada had approximately 5.5 million barrels of oil per day. Iraq, that country had 4.5 million per day. China, just over 4 million per day. United Arab Emirates, just over 4 million per day. Iran, 3.8 million per day, etc. So the United States has emerged as by far the leader in world's oil production. Production of natural gas worldwide in 2022, we actually see a similar picture. The United States is a runaway winner, leading second place Russia by nearly 50%. So this is in billion cubic meters. And we see that the United States has 978.6 billion cubic meters produced. This is almost 1 trillion. Russia, 618 billion cubic meters, and Iran is distant third, followed by China, Canada, Qatar, Australia, and Norway. Distribution of coal production worldwide in 2022. So China leads the world in coal production. China alone in 2022 produced almost 53% of the world's coal production. Now, why is this happening? Why is China so heck bent on producing so much coal? Because its economy has been growing extremely rapidly. I know, up until recently. But in order to actually fuel, quite literally, such a huge economy and to continue to move millions of people from rural areas to the cities, to continue urban growth in China, you need a lot of energy. And the use of coal is seen as essential by the Chinese government. Unfortunately, the side effect of this is horrible environmental pollution, because coal of the three fossil fuels is the most polluting one. Advantages of fossil fuels. First, they're energy dense. They contain a lot of energy relative to their volume. Second, they're cost efficient. More units of energy per unit of money can be extracted from renewables like from non-renewables. So also there exists an extensive, already well-developed infrastructure for extracting, processing, and using fossil fuels. And we also have most of the existing transportation in the world being tied to fossil fuels. I know that presumably in many countries this is changing. Some are far more advanced than others, Norway, for example. But the United States manufacturers, auto manufacturers, also have ambitious plans for moving toward zero-emission vehicles. But for now, both individual and public transportation is expensive relative to the individual and the public who paid and have to maintain them. So if you try to replace the entire infrastructure, transportation infrastructure, that's very expensive. So replacing the extensive existing infrastructure and fossil fuel-based vehicles is a long process. I know that some states like California plan to sell only zero-emission vehicles by 2035. There's a number of other states who have similar goals, and one hopes they actually achieve them, but at this point we cannot be sure. And even if they do achieve them, I think it is still likely that years after that there will still be states in the United States that will allow sales of gas vehicles and hybrid vehicles. So full transition to cars and light trucks that are zero emission might not happen in the United States until the 2040s. So keeping existing infrastructure and existing vehicles is cheap and economically efficient. Like I said, I don't want to sound like a broken record, but at this particular point in economic history, this is particularly salient because of how much public and private debt there already is. So if you look at households in North America, right, and in the United States and Canada, they're saddled with very deep debt, everything from credit cards to student loans. And if you look at government debt in the United States has been rising very rapidly from about $4 trillion in 1992 to about $34 trillion in 2024. So an increase of $30 trillion in 3 decades. So we see that perhaps it's time to be frugal, right, and not spend too much, because excessive spending has its downfall, as discussed in a different video. There are disadvantages to fossil fuels. First, they're non-renewable, obviously. Relative to human life, they are, and to human civilization, since it takes millions and millions of years for them to be actually produced naturally. And they will be gone. Oil and coal will probably be gone before the end of the 21st century. Natural gas may actually last well into the 22nd century. So estimates vary, but if we look at the pattern of recent years, with more and more shale oil and gas being discovered and extracted, I think that the date keeps being pushed further into the future. The date on which fossil fuels run out. I would not be surprised for natural gas to last well into the 22nd century. The second disadvantage is, of course, fossil fuels pollute the environment. And over time, therefore, they do damage to human health and make life less pleasant. This greenhouse effect, since they're carbon-based, they release carbon when burned, and combined with oxygen create carbon dioxide, that's CO2. CO2 acts like a blanket. It traps heat from the earth and causes global warming. So it's like using a blanket when you sleep. The blanket traps the body heat. So in this analogy, carbon dioxide is a blanket. Of the 3 main types of fossil fuels, coal is the most polluting, natural gas is the least polluting, and oil is in between in terms of both production of CO2 and SO2, SO2 being sulfur dioxide. So countries except for China are trying to move away from coal. Next is renewables. Advantages of renewables are obvious. They can be indefinitely used, so they are renewable forever. They do not generate greenhouse gases, so do not lead to pollution, health issues, and global warming. They are so abundant that they can eventually drastically reduce energy costs. Among the renewables, you find sun, wind, geothermal, hydro, and biomass energy. There are also disadvantages associated with renewables. Disadvantages of sun and wind is when the sun is not shining and the wind is not blowing, no energy is generated. Storage/battery technology is expensive, so sun and wind power are less reliable and more expensive than fossil fuels, for now. Wind farms also can ruin views, landscapes, and birds occasionally get killed by flying into windmills. In terms of renewable energy generation, you will see that some countries, and they tend to be small countries who are environmentally conscious, have been able to move drastically toward renewable energy. Now, the fact that they're small makes it possible for them to abandon most other sources of energy. And because their populations are small, their economies are small, so they need a lot less energy than big countries like China or the United States. So Iceland operates on almost 87% renewable energy, Norway almost 72%, Sweden just over half, 51%. So it ain't easy if you're a big country with a rapidly expanding economy. It's tough to be mostly green. Shares of renewables in electricity production are even higher, right? So if you look at the overall picture, overall renewables will be lower because transportation does not move on wind power or hydropower. But if you look at electricity generation, just specifically electricity generation, then obviously the picture is brighter. So in 2022, the share of renewables in the global power mix increased by 1.5% year over year to the grand total of 30%. So in 12 years, we had an increase in the total global renewable production of electricity, and the percentage went from 20% in 2010 to 30% in 2022. That's very encouraging news. So there are ambitious policies in a number of countries, and that really helped. That helped the situation. If you look at the chart, you see the share of renewables in electricity production. You see in Norway, virtually all electricity comes from renewables, 98.5%. In Brazil, which relies heavily on biomass, 89.2%. New Zealand, 86.6%. Colombia, 75%. Canada, 68.8%. Sweden, 68.5%. So we see in extremely high percentages, and we see really here where the problem really lies. It lies in transportation. So if we were to produce electricity only and didn't have fossil fuel-based transportation, if everything was just electric, you can see that economies, even large ones like Brazil, remember Brazil's population is like 210 million people. It's not Norway with its 5 million population. So even larger economies can in fact transition their electricity production almost entirely to renewables. And that's a very hopeful sign, because eventually when we get electric cars and as the prices of renewables decline and we can use more solar and more wind energy to generate electricity, it will be more cost effective, and we will transition our transportation to electric vehicles. This bodes very well for the environment. Nuclear energy is another possible source of energy. Currently, only fission energy use, which is the use of reactors, uranium-based reactors that split the isotopes of uranium to generate energy. France is one of those countries that relies very heavily on nuclear fission. It gets about 62% of its electricity from nuclear power. The United States started using nuclear energy in 1958. US has 56 nuclear power plants and a total of 94 operational reactors, but no new ones have been built in a very long time. Fission has many drawbacks. First, it produces nuclear waste, and this nuclear waste needs to be transported and stored. If you transport nuclear waste by train, there's always a chance of an accident and a toxic spill. If you store it, even though we can store it securely, many people still oppose building storage facilities in their backyard, right? It's NIMBY, not in my backyard. So those are disadvantages. Obviously, you can have a major accident like you did in Fukushima in 2011 due to a natural disaster, a tsunami, or Chernobyl in 1986 due to human error and negligence. So a single major accident that involves a full reactor meltdown and the discharge of material, fissile material into the soil and radiation into the air, poisoning the immediate vicinity, making it uninhabitable for thousands of years to come. This is what makes nuclear fission so incredibly unattractive. Because otherwise it has its own benefits. It produces almost no CO2. So it doesn't contribute to the greenhouse effect, and thus it doesn't contribute to the global warming. But the fear, even of one major accident, led some countries like Germany to commit to moving away completely from nuclear energy. It's that scary. Another possibility is fusion energy. So fusion depends on the fusion of nuclei of hydrogen. And fusion in controlled condition has not been mastered yet. So we have nuclear fusion that is uncontrolled, like the sun is a natural fusion reactor. We had hydrogen bombs tested. That obviously those are fusion bombs. But for a controlled reaction, you have to attain temperature comparable to the temperature on the surface of the sun, at least momentarily, to allow for the atomic nuclei to fuse. And that's very difficult to achieve because this very hot plasma has to be held in place. There's no material known to us that can hold such hot plasma. And the only way to do it is using a magnetic field. We believe we have solved the scientific problem, the engineering problem we have almost solved. So hopefully we will get this ITER reactor, ITER, experimental reactor, operational in 2025. It's located in Europe. It's being financed by a consortium of countries. So I believe it's in southeastern France near the border with Italy. The United States has its own endeavors in fusion energy. Helion Energy is a company that was building a facility in Everett, Washington. I haven't checked on it in a while, so this is an area of research you may want to go into. So yeah, fusion power, if it pans out, eventually will bring limitless energy to the planet. It will produce no CO2. The only cost associated with running fusion power plants is the cost of maintaining them, keeping them operational. So, potentially they can supply the whole planet. Not everyone is a fan of this prospect. Elon Musk, for example, believes that we can power the planet entirely using sun energy. Eventually, not today, but that nuclear is not necessary. Now, aside from France, that uses almost 2/3 of electricity from nuclear, Slovakia heavily relies on it. About 60% of electricity comes from nuclear. Hungary, 47% from nuclear. Belgium, 46%. Slovenia, 42%. Czechia, 36%. Switzerland, 36%. Finland, 35%. Bulgaria 33%. So you see, these are European countries. Other than France, they're all small countries. They all have few natural resources. They don't have a lot of fossil fuels, and they don't want to be dependent on Middle Eastern sources of energy. So what they have done is they have turned to nuclear big time. And the question is, can they eventually unwind that and switch entirely toward renewables? I think we'll get our answer in the next 10 to 15 years. Thank you.